Today we're going to be talking about how to find the integral of a vector function. And in this particular problem, we've been asked to take the integral of this long vector function, which is 3 sine squared t cosine t times I, plus 3 sine t cosine squared t times j, plus 2 sine t cosine t times k. And we've been asked to evaluate this integral on the interval 0 to pi over 2. So we've got a definite integral here. Now, the first thing that's important to know about taking the integral of vector functions is that we can divide this integrand into 3 integrals, one integral for each of our components I, j, and k. The second thing to know is that we're really just integrating here with respect to t. Notice we have this dt here on the end. We're integrating with respect to t, so we can pull I, j, and k outside of the integrand. So if we rewrite this, here's what it looks like. We're going to say the integral from 0 to pi over 2, we're going to take everything here in front of the I. So 3 sine squared t cosine of t, and we're going to add this dt to the end, and we want to multiply this whole integral here by I. So we're going to just put parentheses around this and multiply this by I. So notice we pulled I outside of it, and we separated this coefficient involving t into its own integral. We're going to do the same thing for j and k. So we're going to say plus the integral from 0 to pi over 2 of 3 sine t cosine squared of t, and then dt, close our parentheses, and then we're multiplying that by j. Then we're going to add to that the integral from 0 to pi over 2 of the coefficient here on k, which is 2 sine t cosine t, close it with a dt, our closed parentheses, and then we multiply that by k. So this drastically simplifies our integrand, and now we just need to look at each integral individually. So to try to take the integral of 3 sine squared t cosine t is a little bit difficult. We're going to need to use u substitution. So let's go ahead and set u equal to sine of t. When we take the derivative of u to get du, we say du is equal to cosine of t dt. That'll give us enough that we can plug back in for u and du. If we look at these other two integrals before we do our u substitution here, we realize that we're going to have to make u substitutions for these as well. So that we don't get confused with our variables, let's use a different variable. Instead of doing a u substitution, we'll do a v substitution. So we'll say v is equal to, and this time we're going to set v equal to cosine of t. When we take the derivative, we'll get dv is equal to negative sine of t dt, so the derivative of cosine of t is negative sine t. And then over here for our third function, if we do a w substitution, we'll set w equal to sine of t, and then take the derivative to get dw, which is going to be equal to cosine t dt. Now we can make our substitutions here. We'll get the integral from 0 to pi over 2. When we plug u in for sine of t, notice here we have sine squared t, so we're actually going to get u squared in place of this sine squared t. So we get 3u squared, and then notice here du is equal to cosine of t dt, so we can replace this entire cosine t dt with du. So we have the integral of 3u squared du, which will be really easy for us to integrate. So we've managed to use u substitution to significantly simplify our integrand, and then we just multiply there by I. Now, if we do the same type of simplification with this substitution for the coefficient here in front of our j term, we'll get the integral from 0 to pi over 2. Now here we said v is equal to cosine of t, and dv is equal to negative sine t dt. Well, if we look at this dv value first, we have sine of t and then dt. Here we have negative sine t dt. So if we just essentially multiply both sides by negative 1 so that we have just sine of t dt over here on the right, we know that we're going to substitute in a negative dv for these two values here. And we can just take the negative sign and put it out in front. So we can have a negative 3 here and then just plug in our dv. So we've got dv. And then we said v was equal to cosine of t, so this cosine squared t becomes v squared. So our integral now is just negative 3v squared times dv. We close that and then we multiply it by j. Now here for the coefficient in front of k, we'll get the integral from 0 to pi over 2. We said that w was equal to sine of t, so we're going to get 2 times w. And then we said dw was cosine of t dt, which we find here. So we get dw, and then we can close it and multiply by k. Now we want to evaluate our integrals. If we take the integral of 3u squared, we just get u cubed. So we'll get u cubed, and we're going to be evaluating that on the interval 0 to pi over 2. Keep in mind that our limits of integration for all three of these integrals are defined for t. So essentially we're going to be evaluating on t equals 0 to t equals pi over 2. That just tells us that we have to put our u cubed back in terms of t before we can evaluate on the interval. But I'll just say 0 here to pi over 2. And of course we multiply that by I. Now here for our second integral, the integral of negative 3v squared is just going to be negative v cubed. So we'll get negative v cubed evaluated on the interval 0 to pi over 2. And again, t equals 0 to t equals pi over 2 multiplied by j. And then for our third integral, the integral of 2w is w squared, so we'll say plus w squared evaluated on the interval t equals 0 to t equals pi over 2 and multiplied by k. Now before we evaluate from 0 to pi over 2, we want to make sure we back substitute. So here we said u was equal to sine of t, so we'll call this sine cubed of t evaluated on the interval t equals 0 to t equals pi over 2 multiplied by I. Then here we said v was equal to cosine of t, so we're going to get negative cosine cubed of t evaluated on the interval 0 to pi over 2 and multiplied by j. And then we said w was equal to sine of t, so we'll get sine squared of t evaluated on 0 to pi over 2 multiplied by k. Now we start to evaluate on our interval or our limits of integration. So here for sine cubed of t, plugging in pi over 2 for t, we'll get sine of pi over 2. Sine of pi over 2 is equal to 1. Then we cube it because we have sine cubed of t. So essentially we get here 1 cubed. Then we want to subtract whatever we get when we plug in 0. Well, sine of 0 is just 0, so we'll get 0 cubed, and that's it. Then we multiply by I. Now we want to do the same thing here for the coefficient on our j term. So plugging pi over 2 in for t, cosine of pi over 2 is 0. 0 cubed is just 0. We have this negative sign out in front, so we have essentially negative 0 cubed. Then here when we plug in 0, we want to subtract whatever we get when we plug in 0. Cosine of 0 is 1. 1 cubed is 1, and so we add this negative sign in front, and we have negative 1 cubed. We multiply that by j, and now we just want to simplify the coefficient on our k term. So plugging in pi over 2, sine of pi over 2 is 1, so we have 1 squared. Then we subtract whatever we get when we plug in 0. Sine of 0 is 0, so we have 0 squared, and that's the coefficient on our k term. When we simplify here, we get 1 times I is just I. Here for j, this is going to go away. We have 1 cubed, which is 1, and then minus a negative, these two become positive, so we just have plus 1j or plus j. And then over here for k, we get 1k or just plus k. Once we get to this point, we've simplified as much as we can. We can call this our final answer, and that's how you find the integral of a vector function.